G'day guys, how's it going? So in this video, we're going to start looking at floating point numbers in Rust. And compared to integers, this is actually pretty simple. There's only two types of floating point numbers. And that's a 64-bit floating point number, which is the default, and a 32-bit floating point number. So let's see how we can define one of those. So I'm just going to create a variable here. I'll just go default fp equals, let's say, 2.2. And if I save this, you'll see instantly that it infers that it's going to be an F64, which is a 64-bit floating point number. Okay. Now I can explicitly set that like I could with integers. So I can go explicit, FP, and set that to an F64, and then make it equal to, I don't know, 4.3, right? And then we can do the same thing for, explicit for a 32-bit floating point number, like so, and we can set this to say, I don't know, 1.2. All right, pretty straightforward compared to integers. There's only two types, right? We'll just quickly print these out just to prove that it all works. So I'll just go default fp is equal to default fp, and then I'll just quickly copy and paste that because I didn't prepare this very well, but that's okay. We'll just quickly do this and save. And if we run it, now you can see we've got those three values being set, and they're actually the decimal values of a sign, right? Pretty straightforward, right? Now, you might be asking, when should I use a 64-bit float and a 32-bit float? Well, Rust kind of gives you that answer. They recommend that you just use the F64, the 64-bit float, because in most modern CPUs, there's really not much of a performance benefit using a 32 over a 64. However, like I mentioned in a previous video, the smaller the size, the better the memory use, right? So if there is a situation where you need to store floating point numbers and you don't necessarily need the precision of a 64-bit number. So that's the other thing about floating point numbers, is that the higher the bits, the better the precision, which is why Rust recommends 64 out of the box, because you're getting better precision. But if you're using memory and you don't need that level of precision, that's when you would use an F32, or in this case, a 32-bit floating point number, right? That's the only time I've seen so far that you would need to use that, right? But pretty much most of the time in your application, if you need a decimal, you're just going to use the default F64. Now, just like we did in a previous video, let's just have a quick look at the sizes of floating point numbers. I mean, it should be pretty straightforward given the name, but I've prepared a little script anyway, and I'm just going to paste that in. That basically does similar to what we saw in the integer video, right? Which is, it'll determine I should say byte size, not bit size. So let's just quickly fix that. So I'm just going to quickly rename this. So down here and down here. Cool. So it gets you the size in bytes for each one, as well as the min and max range, right? And you'll see that it'll print out something similar. So let's just run this and quickly have a look. And basically, I'll just make this a little bit bigger down here. You can see a floating point number is 4 bytes in size, and it has a really large range, right? Now, this doesn't necessarily indicate the precision. In fact, I've just realized that I may have used F32 everywhere. I have. So let me just quickly fix this as well. The min and max for the 64-bit isn't correct. So let's run that again. Fixing bugs on the fly, guys. There you go. So that was more what I was expecting. So you can see the precision for 64-bit is very, very large in range, right? So you've got a long range of numbers that you can choose from. And that's basically not even including decimal numbers, right? But there's a lot of bits to work with, considering it's 8 bytes in size. So You can mess around if you like, find out exactly how many decimal points you can go to, but it's just a standard floating point number like any other programming language. So if you've played with floating point numbers before, then you pretty much know, 64-bit precision, right? There's no point me going into that. I mean, most of the time, you're not going to require that level of precision. You're just going to want a decimal number. And in that case, you're probably just going to go with a standard F64 anyway. Like, nobody's going to write out a number with, 36 trailing decimal numbers and all that kind of stuff. Though you may have an application that may require that, but for the most part, it's going to be just a standard decimal number, right? So I'm not going to bother going through that precision stuff. Anyway, that's all I wanted to cover for this video. So I'll see you all in the next one.